Hey Rock Buds, it's Rock Papa. Hope you guys are doing well. Grammy and I are in the southern Appalachian Mountains, and it's the most beautiful fall display that we have ever experienced. So come on up and get your fill of the beautiful colors if you can. Speaking of colors, today we're going to talk about red minerals and the red rocks that they form. We're going to find out where all that red comes from, and we're going to find out that most of that red comes from one particular compound. We'll get into that soon. So if you like this video, please subscribe, and thank you so much to all my wonderful subscribers. I appreciate you and actually love you because you're fellow rock buds. So here we go, red minerals and the red rocks they create. We start off our journey into red rock research with iron. Iron is one of the most common elements on planet Earth, and it seems to get into everything. And where does all that iron come from? It comes from mafic rocks. I'm talking about volcanoes. Volcanoes erupt billions of tons of iron. The iron is easily weatherable. It gets dissolved in the streams, washed into the oceans. Intermediate plutons like diorite and mafic plutons like gabbro and diabase inject iron deep into the crust, and after millions of years those plutons can become exposed to the air and the water, injecting even more iron into the environment. Okay, rock buds, now that we know that iron is everywhere, let's look at some of the minerals and the rocks that are turned red by iron. This is rose quartz, and there are lots of different examples of rose quartz that run from deep red to kind of pinkish like these examples. And as you've probably already figured out, it is iron included in the quartz that gives it the beautiful red color. Hey, what do these rusty screws have to do with iron? Well, everything, because the red on these screws comes from iron oxide, also known as rust. When iron-rich rocks are exposed to air and heat in dry, hot climates, the oxygen in the air oxidizes that iron, turning it into iron oxide, also known as hematite, which is one of several forms of iron oxide. Here's a specimen of hematite, very rich in oxidized iron. In another video, we've talked about the importance of iron oxide or hematite, and this is the example. This is Banded Iron Formation, which is found all over the world and is our major source of iron ore mined for commercial use. All this red iron formation, hematite stuff came into being about 3 billion years ago when algae were in the seas and they were taking in carbon dioxide and pumping oxygen into the seas. All the dissolved iron was oxidized and fell to the bottom, forming Banded Iron Formation. Here's another example of hematite from the Silurian period, which was from about 450 million years ago to about 400 million years ago. This is called Red Mountain Hematite. During the Taconic or Taconian mountain building event, which happened during Ordovician time, the continents were pushing against each other and causing the crust of Eastern America to be compressed and pushed up. After it all ended, the crust relaxed and fell back to where it was, and rift basins formed, and these rift basins filled up with iron-rich sand and mud that became the Red Mountain Formation. Here's a road cut along the Red Mountain Highway in Birmingham, Alabama, showing how much of this Red Mountain hematite was formed. This Red Mountain Formation was the basis for the booming early iron industry in Birmingham that gave it its fame as an early producer of iron. Hey Rock Buds, this same iron-rich hematite formation goes all the way up the eastern United States. In the south here it's called the Red Mountain Formation, but up further north it has several other names. But it's all good old red iron-rich hematite. Hematite iron is often the glue that glues sand particles together, forming sandstone, and that sandstone is red because of the iron-rich hematite Here's some red sandstone from out west that shows cross-bedding marks that tell us that this was once a major sand dune that was blown by the wind. And here is some sandstone pinnacles in the Needle section of Canyonlands National Park, where Grammy and I have spent many a day exploring these beautiful hoodoos, as they are called. When tectonic pushing and shoving metamorphoses sandstone, it turns it into quartzite, but the quartzite still retains the beautiful, rich color of iron. Now let's talk about chert. Chert forms usually way out in the deep ocean, where microscopic pieces of sand get blown out way out into the deep ocean and settle down to form chert layers. And these chert layers are made of cryptocrystalline quartz. That means microscopic sized quartz particles. It is iron that imparts the beautiful red color to these chert samples. Petrified wood is similar to chert in that the quartz is microscopic in size. These trees in the petrified forest in Arizona were ancient, and they were knocked down and covered over by quartz-rich volcanic ash. Later on, groundwater picked up the quartz and the red iron that it contained and actually made a quartz, microscopic sized quartz copy of these trees. Beautiful. Here's a specimen of quartz, muscovite, pyrite, sericite schist, a metamorphic rock. This stuff probably began as quartz-rich material blown out of a volcano that settled on the underwater flanks of the volcano, where it was flushed through with hot water brought up from the bowels of the volcano, along with iron and sulfur that it flushed into these rocks, imparting this purpley red color. We are looking at rough-cut rubies, a beautiful red gemstone that we all know and love. And where does the red color come from? Absolutely right, chromite. But the chromite is made of chromium and iron. Spinel is a close cousin of ruby, and it also gets its red color from chromite. Our red rendezvous would not be complete without garnet, a semi-precious stone that has geological importance. Once again, it is iron that gives garnet its red color. When you find garnet in a metamorphic rock such as schist, it tells you that that schist experienced medium to high grade metamorphism. Okay, rock buds, that's it for red minerals and rocks. Thank you so much for watching, and please subscribe if this video was useful to you. And this is your Rock Papa saying happy rock hunting to all my most excellent rock buddies. Papa out.